Hi, we are from Group 6, so this is our PBL project presentation. We are consist of 5 members. Introduction. MATLAB is a powerful and widely used programming language and software environment for numerical computing, data analysis, and visualization. It is particularly popular in engineering, science, and mathematics disciplines, but its versatility makes it applicable in various fields. MATLAB is a versatile tool that can be used for a wide range of applications, from simple calculation to complex simulation and data analysis.
So, hi and Assalamualaikum. My name is Nur Ifauzna binti Muhammad Sharul and my number matric is DN22089. So, I will explain about project 1, which is a familiarization with MATLAB. So, MATLAB part 1, I will do a part 1. So part 1 is MATLAB as a calculator. So directly, the first one is open the MATLAB and then copy this one. This is the command what I got. So based on the part 1, this is part 1. So this is the part 1 result. This is I copy and paste the. So based on this part, I can say that the provided MATLAB script perform computation with complex number. It initialize to complex number, which is Z and V, and then conduct various mathematical operation. So the script calculate the sum of real part of Z and the imaginary part of V, which is A, the absolute value of the sum of Z here. So and the complete conjugate of V, which is B, the absolute value of the product of Z and V, which is this one, is C. So the sum of angle of Z and V converted to degree in D1 here, and E is the natural logarithm of J is imaginary, which is Z plus V. So the script is structured to showcase MATLAB capability as a sophisticated calculator to complex number manipulator. So after running this script, MATLAB command window display the compute values of the variable, demonstrating the versatility of MATLAB in handling complex arithmetic operation. So number 2, part 2, which copy and paste and then I continue from the previous code, and then the second one is introduce the conversion between rectangular form and polar form. So of a complex number using the function card to pole and pole to card. So which is the polar to Cartesian and Cartesian to polar. So the complex number M is created by adding the previous defined complex number Z and V, and then the Cartesian to polarity function is then employed to transform the rectangular coordinates of M into polar coordinate. So providing the angle of theta and radius R in the command. So it display it in the command window are the magnitude of phase of M here. Subsequently, the pole to card function is utilized to reverse the process converting the polar coordinate back to the rectangular coordinate, represented by the variable x and y. So this example illustrates MATLAB's capability not only in performing mathematical operation with complex number, but also in seamlessly transitioning between different representation, so showcasing its versatility in handling various mathematical tasks involving complex arithmetic. Next is the part 3. So part 3 also same. We just copy and paste this code and from the previous one, and then in the part 3 we need to insert the three sets of different frequency, amplitude, and phase. So here is our different our set for this part 3, which is set 1 is 100 frequency, 100 Hz, amplitude is 2 volt, and phase degree is 0, which is set 2 is 500 Hz, amplitude 1.5 volt, and phase 45 degree. Set 3 1 kilohertz, frequency, amplitude 3 volt, and phase 90 degrees. So after running this, and then we need to insert our frequency, our amplitude, and our phase, and then it will generate this figure. This is for our set 1. So that's all from me. Thank you.
This slide is the summarize of the part 1.
Assalamualaikum warahmatullahi wabarakatuh. Okay, I will continue for part 2, which is MATLAB as a signal generator. Okay, in MATLAB, we can generate signals for various purposes such as testing and simulating signal processing algorithm, communication system, or control system. MATLAB provides a rich set of functions for signal generation and manipulation. For example, the result show an example of a recorded signal that is the sound of a train. To plot signals, MATLAB provide plot and stem functions. To plot 200 samples signal the train with stem by using the following script on instruction. Okay, MATLAB can get samples 100 to 299 of signals. Okay, for this slide, the entered code script produces a chirp sound signal. However, this signal can be modified via equation in the code script. Okay, the pictures show the difference in signals produced with two different Y equations.
So project 2, this is the coding for the case 1. If you can see, this is the output screenshot, audio signal, part of spectrum, amplitude spectrum, and modified spectrum. As we can see, there is a minute difference in the plot between modified and original spectrum.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Aini binti Azmi with metric number CN230010. We'll be presenting about project 2 case 2 on signal analysis with fast Fourier transform in MATLAB. To start off our exploration to generate signal, introduce noise and less frequency using fast Fourier transform, first we need to specify signal parameters. Here we have 1000 Hz for the sampling frequency with signal duration 1.5 seconds and time vector, which is discrete time points using the specified sampling frequency. Step 2 is from the signal. Okay. Here we have two sinusoidal signals with different frequency, which is F1 equals to 50 Hz, F2 equal to 60 Hz. Amplitudes A1 and A2 are set for each sinusoid. Original signal formed by combining these sinusoids. Step 3, corrupt the signal with white noise. When original signal that form here by the two different frequency introduced earlier, we corrupt the signal with white noise. White noise with a defined variance added to the original signal. Then step 4, we plot both signal in the time domain. Visual representation of the original and noisy signals in the time domain can be seen in figure 1. After that, we do the frequency analysis, which is we compute and plot frequency components. Apply fast Fourier transform to the noisy signal to analyze its frequency components. Then we compute single-sided spectrum and plot against frequency, which can be seen in the figure 2, single-sided amplitude spectrum. Then we compare both figure 1 and figure 2, such as figure 2 apply the fast Fourier transform at the figure 1 and we will get the result. MATLAB fast Fourier transformation function efficiently computes the discrete Fourier transform of a signal as assumes periodicity in the input signal. It is fast and effective for analyzing frequency component. Though MATLAB's fast Fourier transform function prefer input lengths that are powers of 2 for optimal performance. However, it can handle other lengths as well. So in conclusion, MATLAB's fast Fourier transform is a powerful tool for signal analysis. We can visualize signal in both time and frequency domain, aids in understanding their character. That's all from me. Thank you.
In summary, familiarizing yourself with MATLAB opens the door to a powerful and versatile tool for numerical computing, data analysis, and visualization. MATLAB's metric-based language, extensive function libraries, and attractive environment make it go-to choice for professionals and researchers in various scientific and engineering fields. For signal analysis specifically, MATLAB provided tools for generating signal, performing Fourier transform, designing and applying filters, and visualizing signal in both the time and frequency domain. That's all from us. Thank you. You can click the icon MATLAB for the MATLAB file.